Lesson 108, similar solids. Here you can see I have two similar rectangular solids here. And what we do is you compare the dimensions here. And they all have to have the same scale factor. So let's look at how we compare it. So similar solids have the same shape and corresponding dimensions are proportional, which just means if I were to write a proportion, so let's just say the height over the diameter has to be the same for the two solids. So this one would be 3 to 4, and this other one would be 6 to 8. But if I were to reduce 6 to 8 by 2 halves, I would get 3 to 4, which is equal to this smaller size. So we would say that they are proportional, they have the same shape. This other one is not similar because the height is not proportional to the height of the smaller one. And so we've also worked with scale factors when we're comparing area and volume. Once you find the ratio of the dimensions, that's also called your scale factor. When you're dealing with area, you take your scale factor and you square it. And when it's dealing with volume, you're going to cube the scale factor because you're dealing with 3 dimensions. Let's take a look at our first example. An architect builds a scale model of a building she is designing. The scale of the model is 1 inch equaling 5 feet. What is the scale factor from the model to the building? So the first thing we need to do is make sure we have the same dimensions. Right now we have inches and feet. So we need to put everything into inches. So I know that 1 foot has 12 inches. So if I multiply 5 times 12, I have 1 inch is the same as 60 inches. So we would say that the scale factor is 60. Letter B, the surface area of the building is how many times the surface area of the model? So when we're comparing area, you take the scale factor, which is 60. Area, you square the scale factor. So 60 times 60 would be 3,600 as our scale, as how many times larger the surface area of the model it would be. And then letter C, the volume of the building is how many times the volume of the model. So again, we're comparing the volumes. So the original, 60, take the scale factor, volume, you cube it. If we cube 60, we would get 216,000. So it's 216,000 times the volume of the model. Example 2. To create a cast bronze sculpture, the ancient artist carved the subject in beeswax. Then the wax was covered in liquid clay and heated. As the cast was heated, the clay hardened and the wax melted away. Melted bronze was then poured into the hardened clay mold. When the metal cooled, the clay was removed, leaving the durable bronze figure. If the artist was commissioned to create a similar solid bronze figure 10 times larger than the original sculpture, how many times as much bronze would be used? So if it's 10 times larger, the scale factor is 10. And since we want to find it 10 times larger than the original, the statue would be, it's a solid, so it's not hollow. That means we are finding volume. And so when we compare volumes, you take the scale factor and you cube the scale factor. So this would be 1,000 times as much bronze would be used in the new bronze figure than the old bronze figure. Next one, the two cylinders are similar. If the lateral surface area of the smaller cylinder is 20 pi square inches, then what is the lateral surface area of the larger cylinder? So we are comparing area. So first we need to find the scale factor. And since they told us that these were similar figures or solids, I can take similar dimensions and I can figure out how much bigger is 2 to 3. So to figure that one out, I can take the larger one, 3 divided by the smaller one, and you get 1.5. So the scale factor is 1.5. And since we are comparing area, I would take my scale factor of 1.5, I would have to square it. And that would give me 2.25. And then I'm going to multiply that by the area, the surface area of the smaller cylinder. So if I multiply that by 20, so 2.25 times 20, that gives us 45 pi square inches. And that would be the lateral surface area of the larger cylinder. And the last two problems. The volume of a model car built to a 1 to 20 scale is what fraction of the volume of the car? So if I take the scale factor and put it as a fraction here, 1 out of 20, comparing volume, so I have to cube everything. 1 cubed is 1, 20 cubed is 8,000. So we would have 1 over 8,000. And the last one, a toy doll modeled after an infant is 1 to 3 scale model. The amount of material required to clothe the doll is about what fraction of the amount of material needed to clothe an infant? So the scale is 1 to 3. And since we're trying to find how much material is needed to clothe the infant, we are looking at area here. So area, we square scale factor. So we would say 1/9 the material needed to clothe the infant. So that is our lesson today on similar solids.